From orbit, Earth looks calm, thin blue air wrapped around a restless planet. Yet below, on a coastal launch pad at sunrise, a towering rocket waits in silence. Steam spills across the ground as engineers finish their final checks. In moments, this machine will try to break free of gravity itself. A rocket launch is one of the hardest engineering feats we attempt. Hundreds of tons of metal and fuel rising on a pillar of fire. The challenge isn't just power, it's precision. Every valve, sensor, and computer must work perfectly, while the vehicle shakes, heats, and accelerates faster than a bullet. To understand how it escapes Earth, we need to see what's inside. Imagine the rocket turning transparent, revealing stacked sections built for a single purpose: deliver a payload to space. At the very top sits the protected cargo, often a satellite or crew vehicle, sealed behind a streamlined fairing. Just below the payload are avionics, guidance computers, inertial sensors, and power systems that keep the rocket oriented within a fraction of a degree. These brains read the vehicle's position and velocity, then command tiny adjustments, gimbaling engines, firing thrusters, or steering fins to hold the planned path. Most of the rocket is propellant. Separate tanks hold fuel and oxidizer, often rocket-grade kerosene or methane, paired with liquid oxygen chilled so cold it forms frost on the metal. Keeping them apart matters. Mixing happens only in the engine, where controlled ignition turns chemistry into motion. Between the tanks and the engine sit turbopumps, machines like jet engines turned into fluid cannons. Spinning at tens of thousands of revolutions per minute, they force propellants through pipes at extreme pressure. In a cutaway, you can watch the liquids surge forward, timed and metered for stability. At ignition, the engine becomes a controlled explosion. Propellants enter an injector, mix, and burn inside the combustion chamber, creating gas hotter than molten rock. That gas expands through a bell-shaped nozzle, accelerating to supersonic speed. The nozzle's shape turns heat and pressure into directed thrust. Now the pad comes alive. The first sparks flare, then the engines ramp to full thrust as the vehicle trembles against its hold-downs. A roar builds into a physical force. When clamps release, the rocket rises slowly at first, fighting weight and inertia, then begins to climb with purpose. As it ascends through the lower atmosphere, the rocket punches into denser air, where drag is strongest. A smooth camera chase follows it past the tower, then up into clouds. Inside, guidance software continuously steers to keep aerodynamic loads manageable while maintaining the fastest safe climb. The core physics is simple, Newton's third law. The engines push exhaust gases downward at high speed, and the equal and opposite reaction pushes the rocket upward. In visuals, imagine arrows of momentum, gas streaming one way, the vehicle accelerating the other. Thrust must exceed weight to lift off. While it climbs, everything changes fast. Altitude rises, speed climbs, acceleration varies as fuel burns away. As propellant drains from the tanks, the rocket becomes lighter, so the same engines can accelerate it more. The flight computer throttles and steers to manage stress, keeping the ride controlled, not chaotic. After a few minutes, the first stage approaches empty. Its job was to lift the heavy stack off the pad and through the thick air. Keeping that now empty structure would waste energy, like carrying a drained battery. So the rocket prepares to separate, using bolts, pistons, and careful timing. Stage separation happens in an instant. The first stage drops away, rotating gently as the second stage lights its engine. For a moment, two vehicles share the frame, one falling back toward Earth, the other accelerating onward. Shedding mass is the secret. The remaining rocket is lighter and far more efficient. Above most of the atmosphere, the rules feel different. There's almost no air, so the exhaust expands into a wide, ghostly plume. The rocket no longer aims straight up. It begins turning sideways, building horizontal speed. Reaching orbit is about going fast enough to keep falling around Earth, forever missing the ground. When the target speed is reached, the engine shuts down and the payload fairing opens, revealing the satellite. Springs or pushers release it into orbit, where it floats weightless and begins unfolding. Far below, Earth curves silently. From explosive chemistry to delicate deployment, it's the same journey, energy carefully guided into a stable path.